Hey guys, so we learned about the mirror equation today that deals with convex mirrors and where to find the image and magnification. So the equation that we have is very much like the lens equation. It's the same equation, as a matter of fact, follows the same principles. And then the magnification equation is even more straightforward, which is just this. Magnification is the size of the image, the height of the image, divided by the height of the object, or it's the negative of the image distance divided by the object distance. So far, no big deal. We did number 1, no challenge. We did number 2, no challenge. Number 3, no big deal. But number 4 provided a little bit of challenge to us. So let's go through it together a little bit. So here we go. What do we know about it? We got a focal length equals 20 centimeters. We're looking for where should an object be placed, so we're looking for DO. We'll just leave that called DO. And it's got a virtual image that it's twice as tall, so we know that the image size equals twice the object size, if you can buy that. Now the distances you can use as sort of surrogates for the image, and that should work because the magnification is 2. So this fact that it's a virtual image means that the image distance is negative. So we have this equation, 1 over the object distance plus 1 over the image distance equals 1 over f. But because it's a virtual image, this is going to be negative here. The image distance will be negative. So we're going to say 1 over, we're going to say 1 over dO minus 1 over 2 dO. Why am I saying that? I thought it was di. Oh wait, di is 2 dO. Why am I subtracting it? Because the image distance is negative because it's on the opposite side. It's a virtual image. It equals 1 over f. So if you bring this math up and keep going with it, you have 1, let's say, how about 2 halves of DO, just to keep it where they have the same common denominator, minus 1 over 2 DO equals 1 over 20 centimeters, which is our focal length. So when you do this, you end up with negative, or those cancel out, and you end up with just 1 over 2 DO equals 1 over 20 centimeters. You can do the math. So 2 times DO equals 20 centimeters. Therefore, DO equals 10 centimeters. And that checks out. All right, the thing that was messing us up earlier, for those of us in 6th period or 7th period, we just didn't take that into account. And then something else that was confusing is just keeping in mind that that's negative image distance if it's on the opposite side of the mirror. If it's a virtual image, that matters. All right, dive in. I hope the rest of this isn't as confusing and frustrating as that was in class, but, you know, maybe we're all working together a little bit more efficiently in class. We can get more done. I've been saying that for a while, but hey, good luck, and I'll see you tomorrow.